Welcome to the fourth video in the series on chemical structures. Today we're going to take a detailed look at compounds with a giant ionic lattice structure. So, what is an ionic compound? These compounds are composed of a metal and non-metal element. And how are these ionic compounds formed? Imagine sodium and chlorine atoms. Sodium, like all metals, loses its outer or valence electron during a chemical reaction. It is therefore oxidized to a positive ion. The chlorine atom, as with all nonmetals, gains the electron from sodium and is reduced to a negatively charged ion. The formation of these oppositely charged ions results in the formation of a giant lattice, a neat and orderly structure in which each positive ion, like a sodium ion, is surrounded by 6 oppositely charged negatives, like chloride ions and vice versa. This structure is super stable because of the strong electrostatic forces holding the ions together. Now, let's chat about the melting point of ionic compounds. They generally have high melting points. Why? It's all due to those strong bonds I mentioned earlier. The amount of energy needed to break these strong electrostatic forces of attraction, ionic bonds, is pretty significant, so the higher the charge and the smaller the ions, the higher the melting point. For example, magnesium oxide has a higher melting point than sodium chloride because magnesium and oxygen ions have higher charges. Neat, right? Here's another cool fact. When you dissolve an ionic compound in water or melt it, it can conduct electricity. In a solid state, the ions are locked in place, but when melted or dissolved, the ions are free to move around. This movement of charged particles allows electricity to flow. Ever wondered about the size of crystals formed when an ionic compound evaporates? It all depends on how quickly or slowly the evaporation happens. If the process is quick, the crystals will be small because the ions don't have much time to arrange themselves. But if it's slow, the ions can form larger, more well-defined crystals. So, let's recap. Ionic compounds form through the exchange of electrons, creating positive and negative ions. These ions arrange themselves into a giant ionic lattice structure, giving the compound a high melting point. When melted or dissolved, these compounds can conduct electricity. And finally, the size of the crystals depends on the evaporation rate. Pretty cool, huh? Understanding these basics can really help you get a grip on chemistry. So, next time you sprinkle some salt on your fries, you'll know a bit more about what's going on at the molecular level. Thanks for watching. If you found this video helpful, don't forget to like and subscribe for more cool science tips. See you next time.